All right, last example. Example 5. Find the area of the surface formed by revolving the circle r equals cosine theta about the line theta equals pi. Should we start with the graph on this one, do you think? I think so. Let's do it. All right, let's start with graphing the function, and then we'll talk about the bounds in a little bit. So we're expecting a circle of radius 1, or sorry, diameter 1, that is. And then we'll just do some t-table work to show that that's true. So plugging 0 in for theta, we get 1. Plugging in, let's do pi over 3, we would get 1/2. Plugging in pi over 2, we get 0. Plugging in 2 pi over 3, we get negative 1/2.
That's this one? Yeah. Okay.
There we go. And then we'll just fill it in with a circle of diameter 1. There we go. Okay. So now for the surface formed revolving it around the line theta equals 0, we'll have, do you mind showing like the little,
Oh, yeah.
yeah, we'll have basically a sphere. Yeah, good. Okay, so now for setting it up, let's get dr d theta taken care of. Let's get r squared figured out. Okay, and then how about this? Let's write the whole thing except leave the bounds off, and we'll have a little chat about the bounds here in a second. So we'll have, 2 pi times the integral. We're going to leave the bounds off for a second. Of, maybe we should write, so if you think about the picture here, the radius would be the y-coordinate, and the y-coordinate in polar form would be, let's write r sine theta for now. Is that okay?
Yeah.
And then now just inserting everything into the arc length formula. So square root of, there we go. Okay. So we'll fill in r in a second with the rule here. We're just going to replace r with cosine theta. But a quick chat about the appropriate bounds. A lot of folks, when they see this, they either want to do 0 to 2 pi, which won't work because the circle would have drawn itself twice in 0 to 2 pi. And then the next best answer would be, next better answer, I guess, would be from 0 to pi, because we know that this circle graphed itself exactly once from 0 to pi. The problem is that if you use both the top half and the bottom half of the circle and rotate it 2 pi radians, which is what this 2 pi causes, then you're actually going to get double the surface, because the top half of the circle creates the whole sphere when you rotate it around, and so does the bottom half of the circle when you rotate it 360 degrees. So for that reason, you really want to use bounds that would draw just the top, probably the top half of the circle. So that would lead us to have bounds from 0 to pi over 2. All right, my friends. So we would end up with 2 pi times the integral from 0 to pi over 2. R is cosine. And then the rest of it is just 1. See, if you don't want to write it, don't.
Oh, yeah.
Let's just save a step.
Whatever.
Erase it off.
Whatever.
Erase it off. You gotta erase both of them.
Oh, yeah, that's true. That's true. Give me a second here.
All right, my friends. How long have you been doing this now? 3.5 hours?
Something.
Yeah, Bryce has been doing math for me for 3.5 hours, bless his math heart. So if you see him later, tell him thank you. All right. All right, now for doing this integral, we're going to use, I think we went with U substitution, right?
Mm-hmm.
Yeah. All right, so if we let u equal sine theta du, ends up being cosine theta. And then writing this integral, changing everything to be in terms of u, let's change the bounds as well. we'd end up with 2 pi times the integral from 0 to 1 of u du. There we go. And then by changing the bounds, we won't have to back substitute, so we can just use the power rule. So we'd have 2 pi times 1/2 u squared from 0 to 1. And then plugging in the upper bound and lower bound and subtracting the results, we end up with just 2 pi times 1/2. And our final answer then is pi square units. All right, my friends, last problem of the year of Calc BC. Congratulations, everybody, to a super great year. Bryce, thank you so much.
You're welcome.
That was way better than me writing with my left hand for 5 hours. All right, take care, everybody. Congratulations.